Let's go ahead and take a look at example 1 from section 11. In this example, we're being asked to do what I refer to as simple factoring. In simple factoring, all we're looking to do is remove any common multiplicative factors from each of the given terms in our expression. You should notice that in each of our three examples, we're doing addition or subtraction between each of our terms. Once we convert into a factored form, we'll be instead performing multiplication between each of our terms. It could be the case that we end up having with division being the operation between some terms, but that won't come up in any of these examples right here. In our first example, 3x squared minus 9x, I'd like to ask myself, what factors do 3x squared and 9x have in common? I can first see that they both have a factor of 3 in their constants. I can also see that there is at least one factor of x that belongs to each. I'm noticing here there's certainly two x's involved in 3x squared, but I want to ask what is common to all terms. And since this one doesn't have two terms of x, it only has one, two x's are not common to everything, but one x is common to everything. So here I'm going to identify that 3 and x are the two common factors that are associated with this term here. To factor out, I want to remember that factoring is essentially doing division. There's a line that I'm about to write right here. I typically don't actually write when I'm doing this myself, but I think it's useful to see it once to help us remind, to kind of reinforce the division that's actually happening with factoring. I am dividing this 3x out of each of my terms. 3x squared divided by 3x minus 9x divided by 3x. You should recognize that if we were to redistribute 3x and multiply it back into each of these terms, 3x here would cancel with each of their denominators, leaving us back with 3x squared minus 9x, our original. So you should be convinced that these are equivalent to each other. To simplify, I can see here that 3 and 3 will cancel. 1x will cancel with 1x on bottom, leaving me just with x in my first term. On the other side here, 9 cancels with 3 to leave us with a 3. X cancels with x, both of them are gone, so we get a minus 3 here as my remaining term. And we're done factoring. The only other thing to say about this is to recognize that every time we do a factoring process, we convert an expression where the primary operation is addition or subtraction between terms into an expression where the primary operation is really multiplication between terms. Factored form says all of our terms are being multiplied. Things that we think of as standard form are when all of our terms are added or subtracted together. Let's do the same thing with our next example. We just got a few more terms here. In our second example, we have 3 terms to look at. We're still looking at terms involving x's and constant coefficients. I'd like to ask myself 2 separate questions. 1, how much constant can I factor out here? So I'm not looking at x's, I'm just looking at the constants. If I look at my constants of 4, 8, and 2, what I see is that they all have a common factor of 2 between them. So I know that a 2 is one of the terms that I'll factor out. What I also can see here is that there are 5 x's, 4 x's, and 2 x's. I can verbalize this by saying every term in my expression has at least 2 x's, so I can factor out an x squared from all of my terms. When I divide out 2x squared from terms like 4x to the 5th, remember I'm doing division. I'm not going to write the division here, but it's still the same type of division that we're seeing happening over here. 4x to the 5th divided by 2x squared, well, 4 divided by 2 leaves me with 2. X to the 5th divided by x squared leaves me with x cubed. There are 3 of the x's still remain after factoring out 2 of them from 5 of them. Similarly, 8x to the 4th, I'll go ahead and divide 8 by 2 to get 4. I'll divide x to the 4th by x squared to get x squared. For my final term, 2 divided by 2 is 1, but don't forget our negative. X squared divided by x squared, also 1. So it really looks like we just have a minus 1 here. We've divided out all the parts. 2x squared divided by 2x squared is 1. So we are subtracting off a total of 1 inside of the parentheses here to wrap up this example. Again, we used to have addition and subtraction being the primary operation between terms. We now have multiplication being the primary operation between our 2 terms in our factored form. For our final example, we get a little bit more going on here. We see that we don't just have constants and x's, we have constants, x's, and y's. So we just need to think about 3 different things that we might want to factor out. The first question then that I'll ask myself is, what constant terms do I want to factor out here? When I say my constants, here I notice that all of my constant coefficients all had a factor of 2, so it was removed. Here my constant coefficients are 3, 4, and 2. It doesn't actually seem to me like there's anything reasonable to factor out from these. What I really don't want to do is create any fractions, so I'm going to avoid doing that. I'm noticing that, for example, if this 3 were instead of 6, then all of my terms would be even, so I would factor out a 2. In this case, though, 2, 3, and 4, no common factors that are common to all three of them, so I'm not going to factor out any constant parts. My next question is, how much x should I factor out? I have 2x's, 2x's, and 1x. Since every term has at least 1x is how much I'll factor out. Similarly with the y's, I have 3y's, 1y, 1y. Therefore, every term has at least 1y, so that's what I'll factor out. Now I just have to decide what are all my terms remaining. Notice that all I'm going to do is essentially remove one count of x and one count of y from each of my three terms here. All the constants got left alone. We didn't factor out any constants. So it looks like I should be left with here the 3's left alone. We had 2x's and we removed 1, so now there's 1x. We had 3y's and we removed 1, so now there's 2y's. 3xy squared. Minus, we left the 4 alone, no constants were factored out. We had 1y, but we factored it out, so there's no y terms. We had 2x's and we removed 1, so there's a single x remaining. For our final term, we left the 2 alone. We had 1x and we factored it out. We had 1y and we factored it out. So both the x and y have been factored out to the front. So that 2 is alone on the inside there. It looks like this is my factored form. Again, realize that we used to have addition and subtraction being the primary operation between terms, but now we have multiplication between our two terms being our primary operation here.